Today, we are going to teach you how to control the camera in LTX 2.3. For example, let's say we have some videos on hand, and the camera movements in these videos are absolutely beautiful if we want to apply those camera movement effects to our AI-generated videos. We call this kind of technique camera control or camera transfer. Currently, the best camera transfer technology we have encountered is probably Uni 3C, which can be widely applied to WAN 2.1 and WAN 2.2 models. Although we are also talking about camera transfer technology today, it is quite different from the Uni 3C we discussed before. The camera transfer we are covering today is primarily based on a trained LoRa. In this video, we also did some experimenting. For instance, we previously explained the mesh to motion extension, which can automatically generate some camera animations. Can these custom camera animations also be applied to this camera transfer technology? We will explain all of this in detail in this tutorial. The LoRa we are introducing today is called Camera Man. We can see many sample videos on its Hugging Face page. In these videos, the left side is the reference video and the right side is the new video generated using this reference video combined with the LoRa we are talking about today. Take a look. This camera transfer effect is actually very obvious. You can clearly see that this LoRa is an IC LoRa and its size is only a bit over 300 megabytes. We can briefly look at some relevant information about the training process of this LoRa. First of all, it only took 77 videos to train this LoRa. So the generalization ability of this model might not be incredibly strong. And these 77 videos are roughly composed of the following types of camera movements, which are relatively single camera movements without complex combined states. Therefore, if your reference video has extremely complex camera movements, it might fail to render them when using this LoRa. Additionally, the author mentioned that this LoRa has some limitations. First, this LoRa is currently in the experimental stage, so the results might not be very stable. Second, as we just mentioned, because its training data consists of simple camera movements, it might not be able to transfer complex camera movement effects perfectly. Another point is that the LoRa's author only tested it on image-to-video generation. No related testing has been done on text-to-video generation. Yet, therefore, when we explain the corresponding workflow, we will still use image-to-video as the blueprint to guide you. To make the demonstration easier, I have also deployed the workflow to Running Hub in the ComfyUI space. Running Hub is a fantastic online platform because whenever new extensions and new models appear, they always follow up immediately. Plus, Running Hub provides an online communication platform for ComfyUI creators, where you can find tons of inspiration and testing workflows. All right, next let's briefly analyze this workflow. This workflow is actually an IC LoRa workflow, and it is pretty similar to the official version provided by LTX, with just a few slight differences. Since we have already explained the entire workflow in previous videos, we will just briefly review it here. First, from an overall structure perspective, this is a two-stage sampling workflow. The first sampling stage is used to generate the base video, and the second sampling stage is for video upscaling. The main model we are using here is still provided by Kijai. Because the workflows provided by Kijai are constantly updating, we recommend you try your best to use the latest version. Moreover, for the upscale model part, we selected a spatial upscale model, specifically a 2x upscale model. After the main model, we chained the LoRa we are talking about today, called Camera Man, and set its weight to 1. You need to pay attention here. We are loading an IC LoRa, so we need to use a node called ICLora Loader. After loading the corresponding LoRa, this node will output a model, and it will also output something called the latent downscale factor. In the officially provided workflow, this downscale factor is useful. But in the workflow we are using today to talk about this LoRa, please note that we did not use this downscale factor. As we emphasized earlier, we are using an image-to-video workflow, so we need to have a reference image. We still recommend that you configure the resolution used for the entire workflow in advance. Whether it is the reference image or the subsequent reference video, they should all be processed and scaled according to the corresponding resolution. Here, I am using a landscape reference image, and its resolution is 1280 by 960, what we call a 4:3 aspect ratio. Regarding reference videos, there are two different types. The first type is videos with great camera movement that you can collect yourself in your daily life. The second type is what we mentioned earlier. We can use mesh to motion to generate some camera movement reference videos. But be careful, guys, even though both types of videos contain camera movement information, the resulting effects are completely different. We will demonstrate this in detail later. Once you have your reference image and reference video, you can use the following two nodes to add our reference image and camera movement video into the sampling process. For the first sampling stage, the resolution we generate is only half of the target resolution, which is 640 by 480. Then after one upscaling pass, we hit 1280 by 960. You guys are all very familiar with this process. In this example, the reference image we use is a classical beauty. And this image itself has a very beautiful low-angle shot, giving the whole picture a strong cinematic feel. As for our reference video, its camera movement is quite intense but not overly complex. The camera constantly zooms out and pushes in around the character. Let's look at the final generated video effect. This camera animation has successfully been transferred into our video. The overall effect is actually pretty good. However, we still need to remind you guys that this video is not an ideal camera reference video because it blends a bit too many types of camera movements. For this IC LoRA, as we mentioned earlier, it was trained on only 77 videos. Therefore, its reference videos are all relatively simple. When we choose a reference video for camera movement, we should try to stick to this similar principle. For instance, let's look at the next example. The reference image is a beauty drinking a bottle of Coca-Cola. The camera movement in the reference video is quite simple. It only features one type, which is what we often call zooming out. We keep all the other content in this workflow unchanged. The final video presents a zoom out camera effect, and outside the original frame, other characters continuously appear, which also enriches the content of the entire video. Through this comparison, you will notice that you shouldn't choose a reference video that is too complex because overall the capability of this LoRA is still limited. Next, let's discuss a very interesting topic. Because the movement of the camera and the character or the main subject in the video is relative, sometimes it is really hard to tell if it is the camera moving or the character moving. Take the following example. Our reference image is an Eastern beauty holding a gun, seemingly in a shooting competition. Now look at the reference video. This video is super interesting. Is the camera moving? Or is the character moving? Actually, this is quite easy to distinguish. It is the camera moving because we can clearly see that the character's posture has not changed at all. If we use this kind of camera movement video to generate a new one, take a look. First of all, the effect of this video is fantastic. But let's guess again, is the camera moving or the character moving here? This one is obviously the character moving. Because if the camera were moving, the background would rotate along with the camera, not just the character. But as you can see, only the character's angle is changing. The background behind her, although it has some slight movement, is clearly not rotating. Therefore, sometimes we really don't need to overthink whether it is a camera animation or a subject animation. We only have one standard for judging, its overall aesthetic appeal. We have done a lot of tests on this. As long as you ensure the quality of the reference image and keep the camera movement video from being too complex, it generally works without any problems. However, there are a few more things you need to pay attention to, which might not be so easy to spot. The first is regarding prompts. When using this LoRA, try not to include too many descriptions about actions in your prompt, especially descriptions of camera movements. Because as we just mentioned, the camera's movement and the character's movement are often relative. So the more actions you describe and the more specific they are, the more likely they are to interfere with the performance of the overall camera movement. For example, let's look at the next example. For the reference image, we chose a beauty teaching in a classroom. For the reference camera movement video, we used that zoom out video from earlier. In the first workflow, my prompt was written very simply. It basically just described this teacher giving a class, her general appearance and clothing, and the overall classroom scene. There were no highly detailed descriptions of the character's actions. Let's look at the final generated result. It is absolutely fantastic. There is a very obvious zoom out or camera pullback effect. Now, if we keep this reference image and reference video exactly the same, but I designed 3 extremely complex actions for this character within these 5 seconds and write them into the prompt, let's see the final generated effect. you will find that the camera movement is totally gone. The reason is exactly what we just mentioned. The camera's movement and the character's actions affect each other. Alright, next let's address a question many of you are very curious about. Can the reference videos generated by the Mesh to Motion extension we talked about before be used with this LoRa? Mesh to Motion is an extension we previously introduced to you. It contains many 3D models and basic shapes, including humans and animals. It also has many action presets and camera animation presets. So I was also pondering this question: if I use Mesh to Motion to generate a reference camera movement video, can it be used in this loader? For how Mesh to Motion generates videos, you can refer to our previous video, which has a very detailed explanation. The reference video I just generated features the camera moving around the character. Then we keep the entire workflow unchanged. I am just swapping out this reference video. Let's look at the final generated result. Do you notice how bizarre this effect is? The character even morphed from our reference image into a scene resembling the 3D character I generated. And this is not an isolated case. I tested it a lot. And basically, this problem occurs every time. So let me give you the conclusion right up front. Reference videos generated by Mesh to Motion cannot be used with the LoRa we are discussing today, because it will completely ruin the generation of the entire video. You guys can probably guess the reason, because the entire LoRa was trained using only 77 videos as training data. I believe all the training data consists of real-life footage, not the 3D model character animations I am using right now. This type of animation probably cannot effectively drive this LoRa to work. But regardless, you will find that Cameraman's overall effect for camera transfer is still pretty good. Of course, we would love to use a more flexible method, like Mesh to Motion, to generate corresponding camera reference videos, so we have more flexibility when customizing videos. But there is nothing we can do about it right now. This LoRa doesn't perform particularly well with this kind of control video. We hope that better versions will be released in the future. Here, I want to remind everyone once again, the quality of the camera work, the cinematic language, and the camera movement effects are absolutely crucial to the overall quality of a video. So I hope you all pay close attention to it. That is all for today. What are you waiting for? Go ahead and try it out for yourself. Follow me to become someone who truly understands AI.